Okay, hydrocarbons. First question. Give 2 conditions used to crack alkanes. Well, you've just got to know this. Commit this to memory. To crack alkanes, you need a temperature of 400 to 700 degrees C. And you need an aluminium oxide catalyst. Oxide catalyst. Okay, just got to know that. Those are the conditions necessary for cracking. Okay, next question. Complete the sentence. When alkenes react with bromine water, the colour changes from orange to what? It changes from orange to colourless. Okay, 1 mark. Simple as that. The reason is, okay, if you've got your bromine water, bromine is Br2, okay? So, and bromine atoms form 1 bond, so the bromine molecule, Br2, looks like that. It's 1 bromine atom, single bond to another bromine atom. In water, when you add the alkene, an alkene has a double bond in it, okay? Let's say the alkene is ethene. The bromine molecule reacts with this double bond and you end up with this molecule here. The 2 bromine atoms end up on the 2 carbons of the alkene, and you've no longer got a bromine-bromine bond. See, that bond doesn't exist anymore. And it's that bond that gives this the orange colour. When this is in solution and all of the bromine is reacted with all of the alkenes, so the alkenes have mopped up all the Br2, there's no Br2 left, the solution is colourless. Okay, moving on. Complete the displayed structure of butane. Okay, they've given us, this. Right, and they've told us it's butane. We have to complete the structure here. So butane, that means 4 carbons. For GCSE, you need to know the first 6, the names of the first 6 carbons. So 1 carbon is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane. So butane is 4 carbons, so start there and add the remaining 2 carbons. And now we've got all the carbons in place, now we add the hydrogens. And carbon forms 4 bonds. So let's look at this carbon. It's currently got 2 bonds to it, to that carbon and that carbon, so there's space for 2 hydrogens. Okay? This carbon has currently got 1 bond to it, so there's space for 3 hydrogens. Like so. And there we go. We've completed the structure of butane. Good. Right, calculate the energy released by 1 gram of decane in kilojoules. So we've got this apparatus of a beaker with a thermometer in it full of water, and there's the little spirit burner underneath in which we place the decane. That's meant to be a flame. Okay, and that's the hydrocarbon inside burning. So, right, what do we got to do? Calculate the energy released by 1 gram of decane in kilojoules. So we're told that 1.2 grams of decane releases 24.36 kilojoules. Okay? And we have to work out the energy released by 1 gram of decane. So this is maths, it's a ratios question. We've got 1.2 grams of decane corresponds to 24.36 kilojoules, right? And we want to find out what 1.0 grams of decane releases. We want to find that there. So, ratios question, maths. What have we done to go from there to there? To turn 1.2 into 1, we've divided by 1.2. So, we do exactly the same here. We divide by 1.2. So, in your calculator, do 24.36 divided by 1.2 and you get 20.3 kilojoules. And that's the answer. Okay. Next, suggest one improvement to this apparatus for more accurate water temperature increase and say why it's an improvement of 2 marks. Okay, well it's a standard question, standard setup. You get this question a lot. The hydrocarbon that you're burning, in theory, all of the energy that hydrocarbon you're burning is meant to go into the water and you measure the water temperature increase. In reality, you don't get anywhere near that. There's lots of heat loss. I think the most obvious heat loss in this case is, well, you could say the flame to the surrounding air. It's heating some of the air, not the water, to the beaker. But probably the best one is to say, if you added a lid to the beaker, it would help reduce heat loss by, through the top of the beaker. So, to answer the question, so one improvement is a lid, 1 mark. Why is that improvement? It reduces heat loss from the water during the burning, 2 marks. Okay, next question. The students noticed a black substance forming on the bottom of the beaker. What is this substance and why is it produced for 2 marks? Okay. Whenever you're burning something and you get black stuff appearing, it's soot. Right, so the answer is soot, which is carbon. Okay? Now, this being an exam and them being fussy, the examiner's being fussy about what you say, and if you're not sure in an exam, this is a general tip for all exams, if you don't know whether to say soot or carbon, just hedge your bets and put both. Okay? You're not going to get marked down. As long as you've got the right answer, you'll get marks. Okay. Why is it produced for the 2nd mark? Whenever you see soot, the reason it's produced is because of incomplete combustion. Okay? That means that there isn't a sufficient oxygen supply. If this were burning with complete combustion, there'd be no soot produced. But in reality, that's difficult to achieve, and often you get incomplete combustion. Okay. Give 2 reasons why hexane is the best of the 4 fuels. Well, I haven't written out the table I've given you in the question sheet, but you can see it at the beginning of the video. So, looking at the numbers in that table, why is hexane the best of the 4 fuels? Well, the first reason is that it releases the largest amount of energy per unit mass or per gram. Okay? And that energy is 20.74 kilojoules. Okay? And that's per 1 gram. And that's the important figure. Okay? That's the largest of all of the fuels listed. I think they're trying to trip you up slightly because the column for total energy release actually has the smallest number, which is 16.80 kilojoules. But that's total energy. The important figure is the amount of energy released per unit mass, or per gram. So ignore the total, don't worry about that. That's the important figure, and that's the largest. So that's the first reason. The second reason is, well, in the final column it says it produces the least soot. Okay, we've got to write a mini essay and explain the advantages and disadvantages of using hydrogen instead of petrol as an energy source. This is all the information they've presented us with, and we've got to extract 6 marks. So, where shall we begin? Well, there are some gifts here, so let's start with those. Look at this. Energy released by combustion of 1 gram. It's quite simply more for hydrogen, so that's an advantage. So let's have advantages of using hydrogen over petrol. So, more energy per gram released, 142 instead of 47, okay? Now, this is important. This is an essay question. It's not enough just to say hydrogen releases more energy per gram. You have to say, therefore, it's more efficient. Or, therefore, you need less fuel. That's really important, okay? You have to use the word therefore, or so, or thus. They're really important words. Get used to using them. You have to explain why the thing you said is important. Okay, right. What else can we say? Advantages of using hydrogen over petrol. Well, look at that. The combustion of hydrogen produces only water as a product, and water is harmless to the environment. So that's another advantage. What else can we say? Look at that. Petrol, the combustion of petrol, carbon dioxide is a product for petrol, and that's a greenhouse gas. Therefore, it can lead to global warming. So, petrol, CO2 is a product. There's another one. What else can we say? Advantages of hydrogen. Well, this is petrol, is the combustion of a hydrocarbon. And whenever you have combustion of a hydrocarbon, you can have incomplete combustion, which can lead to carbon monoxide, which is toxic. So that's another advantage of hydrogen. You can't get carbon monoxide produced because there's no carbon on the left-hand side. Okay, what else can we say? I'll leave the top line for the moment. That's a disadvantage of hydrogen. So, what have we got here? Well, they tell us that sulfur is an impurity in crude oil, and petrol is produced by the fractional distillation of crude oil. So, the fractional distillation of crude oil, because sulfur is an impurity, it leads to sulfur dioxide in the atmosphere, and that leads to acid rain. So that's another good reason to use hydrogen instead of petrol, because acid rain is harmful to the environment. Okay, we're going to have to look at this now. What else have we got? Right, we'll just do one more advantage. So, petrol and hydrogen are both produced from non-renewable sources here, okay? they've told us that petrol comes from crude oil and hydrogen comes from natural gas. However, hydrogen can be produced in other ways. You can produce hydrogen, for example, by the electrolysis of water, effectively going backwards, going the opposite direction here. You split water into hydrogen and oxygen, and the energy to do that can come from solar panels, so ultimately the sun. That's just one way. So that's another advantage. Alternative sources of hydrogen. Okay, let's do some disadvantages. Right, disadvantages of using hydrogen instead of petrol. Well, there's the big one. At room temperature, it's a gas. And that means that storage and transfer of hydrogen is a problem. Petrol's a liquid, so it's much easier to store it and transfer it to the car. But gas, we're working on alternative ways of storing hydrogen, but it has to be compressed and stored in a cylinder under pressure. And that is more difficult than storing a liquid. Okay, so that's a reason. Another reason is that hydrogen gas is highly flammable. So it's more likely to, were there a leak, to ignite than the liquid petrol. So let's just say highly flammable. Plus the fact that it's probably stored in a cylinder under pressure, it's more likely to lead to a dangerous explosion. Okay, what else can we say? Right, you're going to have to fall back on your vast knowledge of hydrogen as an energy source here. What else can we say? Well, at the moment, where are all the filling stations? There's plenty of petrol stations, but where are the hydrogen stations? There are, as far as I'm aware, very few hydrogen filling stations for cars, for hydrogen cars out there. Also, where are all the hydrogen cars? Current engines, petrol engines, you can't just shove hydrogen in them and they work. So that means you need to modify or just build new hydrogen powered cars, and that's expensive. So that's another disadvantage of hydrogen. What else have we got? That's pretty much it. That's all I've got. So there's 6 for at least 10 points there. So you should be able to extract 6 marks out of that. But do remember the words therefore, so, and thus. Use them all the time. Whenever you say something, say why you said it, why that's important. For example, hydrogen produces more energy per gram when combusted, therefore it's more efficient. It's an essay, a mini essay question, and that's important to get you the full marks. Yes, right. I just want to say, to finish off, I told you that a disadvantage of hydrogen is that you're more likely to get an explosion in the event of a leak or a crash, or 2 hydrogen cars crash or something. And that will get you the marks in the exam. I do just want to say, however, that don't go thinking that if and when these hydrogen cars exist and when we have a crash, which is inevitable, that they're suddenly going to explode in a huge ball of flames. That's not necessarily true, okay? there's a lot of research going on in this area at the moment, and there is a school of thought that says, according to my research on this, were there to be a crash and a gas leak, a hydrogen gas leak, firstly, it's not necessarily going to ignite straight away. Why should it? And secondly, the gas leak, because it's a gas, it will escape quickly. So actually, if it doesn't ignite, it's released into the atmosphere quickly, and that removes the danger of the flammable material quite quickly. My point is that, like I say, there's a lot of research going on in this area, and there is apparently strong evidence to suggest that two hydrogen fuel cars crashing is nowhere near as dangerous as the image might be. I don't want to get on my soapbox about this forever. I'll leave it there. My point is that hydrogen powered cars are new and exciting. There's a lot we don't know about them. Get on the Tinternet, do some research, watch some videos on it. It's very interesting stuff. But as far as this exam question is concerned, just say that it's more flammable than petrol, and you're more likely to get an explosion in the event of a crash. Okay, enough soapbox stuff. Watch some videos, read some internet stuff. It's very interesting. Promise.